Term paper, Electrical Vehicle Charging Infrastructure. This paper explores the critical role and evolving landscape of electric vehicle, EV, charging infrastructure, examining its various types, core components, global deployment, and the challenges and innovations shaping its future. It aims to provide a comprehensive overview essential for understanding sustainable mobility. Introduction. Powering sustainable mobility. The rapid adoption of electric vehicles, EVs, is a cornerstone of global efforts to combat climate change and transition to sustainable transportation. However, the success of this transition hinges critically on the development of a robust and accessible charging infrastructure. Without a reliable network of charging points, consumer confidence in EVs will remain low, hindering widespread adoption. EV charging infrastructure refers to the entire ecosystem of technologies, services, and policies that enable the transfer of electricity to power electric vehicles. This includes everything from the charging stations themselves to the underlying electrical grid, payment systems, and maintenance protocols. Its importance cannot be overstated in today's world, as it directly impacts energy security, air quality in urban centers, and the economic viability of the EV market. This paper will delve into the intricacies of this crucial infrastructure, exploring its current state, future potential, and the challenges that must be overcome to realize a truly sustainable transportation future. Types of EV charging infrastructure. EV charging infrastructure can be broadly categorized into different levels based on charging speed, power output, and typical use cases. Understanding these distinctions is fundamental to designing an efficient and user-friendly charging network. 1. Level 1 charging speed, slowest, 2 to 5 miles of range per hour. Cost, lowest, utilizes standard household outlets. Use case, overnight home charging, ideal for plug-in hybrids or EVs with smaller batteries. 2. Level 2 charging speed, moderate, 10-25 miles of range per hour. Cost, moderate, requires dedicated 240V circuit installation. Use case, public charging stations, workplaces, retail, home charging for faster top-ups. 3. DC fast charging, level 3, speed, rapid, 6,200 plus miles of range in 20-30 minutes. Cost, highest, significant infrastructure investment. Use case, highway corridors, urban charging hubs, fleet charging, emergency top-ups. The optimal mix of these charging types depends on local needs, vehicle types, and available grid capacity, requiring careful planning for effective deployment. Core components of EV charging systems. A fully functional EV charging ecosystem relies on a complex interplay of hardware, software, and energy sources. These core components work in concert to deliver electricity efficiently and reliably to electric vehicles. Charging stations and connectors. These are the physical points where EVs plug in. They vary in power output and connector types, e.g. J1772, CCS, CHAdeMO, Tesla, ensuring compatibility with different EV models. Power grid integration. Seamless connection to the electrical grid is paramount. This involves managing load balancing, ensuring stable power supply, and potentially utilizing smart grid technologies to optimize energy distribution. Software and payment systems. Charging networks are managed by sophisticated software that handles authentication, billing, station monitoring, and user interfaces, such as mobile apps. Interoperable payment solutions are crucial for user convenience. Renewable energy integration. To maximize the environmental benefits of EVs, charging infrastructure increasingly incorporates renewable energy sources like solar panels and wind turbines, directly or indirectly powering charging stations. Each component must be robust, scalable, and interconnected to support the growing demands of the EV revolution. Global and Indian scenario. The deployment of EV charging infrastructure varies significantly across the globe, influenced by policy, technological advancement, and consumer demand. India, while an emerging market, is rapidly catching up with ambitious targets. Global leaders China. leads the world in charging infrastructure deployment, driven by strong government support and a massive EV market. Focus on both public and private charging. USA. Significant investments through federal and state initiatives, with a growing network of public and private charging points, particularly DC fast chargers along highways. Europe. Strong emphasis on interoperability and cross-border charging, with countries like Norway and the Netherlands boasting high densities of charging stations and a clear push towards renewable energy integration. India's initiatives. FAME II scheme. The faster adoption and manufacturing of hybrid and electric vehicles in India scheme provides subsidies for EV purchases and charging infrastructure development. State initiatives. Various state governments are introducing EV policies, offering incentives for charging station installation and promoting EV adoption. Current statistics. While still nascent, India's charging infrastructure is experiencing rapid growth, with hundreds of new public charging stations being added annually, projected to accelerate significantly in the coming decade. India's commitment to clean energy and ambitious EV targets positions it as a key player in the future of sustainable mobility. Key challenges in infrastructure deployment. Despite the immense potential, the expansion of EV charging infrastructure faces several significant hurdles that require innovative solutions and concerted efforts from stakeholders. High installation costs. The capital expenditure for setting up charging stations, especially DC fast chargers, can be substantial, hindering rapid expansion without sufficient subsidies or private investment. A sudden surge in EV charging demand can strain existing electrical grids, necessitating upgrades and smart grid solutions to manage load effectively and prevent blackouts. Land availability and regulatory hurdles. Finding suitable land in urban areas for charging hubs is challenging. Additionally, navigating complex permitting processes and inconsistent regulations can delay deployment. Lack of user awareness and standardization. Many potential EV buyers are apprehensive due to perceived charging difficulties. A lack of universal charging standards can also confuse users and complicate infrastructure planning. Future prospects and innovations. The EV charging landscape is continuously evolving, with exciting innovations poised to transform how we power our vehicles. These advancements promise greater convenience, efficiency, and sustainability. Wireless charging technology enables EVs to charge simply by parking over a pad, eliminating the need for physical cables and connectors, ideal for public parking lots and autonomous vehicles. Smart AI and IoT-based charging utilizes artificial intelligence and the Internet of Things to optimize charging schedules, predict demand, and integrate seamlessly with smart homes and energy management systems. Vehicle-to-grid (V2G) systems allow EVs to not only draw power from the grid, but also feed excess energy back, acting as distributed energy storage and stabilizing the grid during peak demand. Renewable-powered charging hubs are integrated charging stations that generate their own electricity from solar or wind, often paired with battery storage, making them energy independent and highly sustainable. Environmental and economic impact. The shift to electric vehicles, supported by a robust charging infrastructure, promises substantial environmental and economic benefits, contributing to a more sustainable and prosperous future. Environmental benefits. Reduced air pollution. EVs produce zero tailpipe emissions, significantly improving urban air quality and reducing respiratory illnesses. Lower carbon footprint. When powered by renewable energy, EVs drastically lower greenhouse gas emissions compared to internal combustion engine vehicles. Noise reduction. EVs operate silently, contributing to quieter cities and enhanced quality of life. Economic benefits. Energy independence reduces reliance on imported fossil fuels, bolstering national energy security. Job creation. Growth in the EV and charging infrastructure sectors creates new jobs in manufacturing, installation, and maintenance. Cost savings. EV owners benefit from lower fuel and maintenance costs, while grid operators can utilize V2G for efficiency. The long-term advantages of this transition far outweigh the initial investment costs, paving the way for a greener economy. Recommendations for accelerating deployment. To effectively accelerate the deployment of EV charging infrastructure, a multifaceted approach involving policy, technology, and public engagement is essential. Streamline permitting and regulations. Simplify and standardize the process for installing charging stations, reducing bureaucratic hurdles, and accelerating project timelines. Incentivize private investment. Offer tax breaks, grants, and subsidies to private companies for investing in charging infrastructure, particularly in underserved areas. Expand grid infrastructure. Invest in smart grid technologies and grid upgrades to ensure the electrical network can handle increased demand from EV charging. Promote interoperability and standardization. Encourage the adoption of universal charging standards and roaming agreements between charging networks to enhance user experience. Public awareness and education campaigns. Educate consumers about the benefits and ease of EV charging, dispelling myths and fostering confidence in EV technology. EV charging infrastructure is the backbone of the sustainable mobility revolution. With technological innovation, strong policy support, and renewable energy integration, it will pave the way towards a cleaner, greener, and smarter future. The journey towards a fully electrified transportation system is complex, but the path is clear. A robust, accessible, and intelligently managed EV charging infrastructure is not merely an accessory to electric vehicles, it is their essential enabler. From the foundational Level 1 chargers to cutting-edge wireless and V2G technologies, each component plays a vital role in building a resilient energy ecosystem. As global leaders accelerate their efforts in emerging markets like India, commit to ambitious targets, the challenges of cost, grid capacity, and standardization are being met with innovative solutions. The integration of renewable energy and smart technologies promises not only a reduction in carbon emissions, but also a more efficient and stable energy grid. The environmental and economic benefits are profound, contributing to cleaner air, energy independence, and job creation, driving towards a future where every charge powers progress.